Exercise 7.2. Calculate the area and circumference in each of the following. Give your answers to three significant figures where necessary. Okay. Before we start this exercise, we should be writing down the formulas for area of a circle, that is pi r squared, as well as the circumference of the circle. This is actually the perimeter of the circle, which is having the formula 2 pi r. Or since we know that diameter is equal to 2 times the radius, so we can write down pi times 2r, that is pi d. If we are given with the diameter of the circle, then we will be using pi d, and if we are given with the radius, so we can use this formula 2 pi r. Okay, now it's part A. The radius that is given, that is 4 meters, and we need to find out area. Pi r squared, pi times 4 squared, that is pi times 16 pi. And now if this is a question of paper 1, so we can write it down like 16 pi meters. And if it is a question of paper 2, in which we can use the calculator, so in that sense it would be 50.265. 50.26548, like. And since we need to have the answer to three significant figures, so we'll write it down to 50.3. This is our fourth significant figure, which is greater than 5. So this digit, which is the third digit, that would be rounded up. So 50.3 meters. That is going to be its answer. Now for circumference, 2 pi times r. 2 times pi times r, the value of the radius is 4. So we can write it down to 8 pi meters, or it will be 8 times the value of pi, 25.1327. So giving the answer to three significant figures, 25.1. This is the fourth significant figure, fourth digit, so which is less than 5. So we are not going to round it up. This will be 25.1 meters. So that is the answer of the circumference of the circle given in part A. So this is how these questions are to be done. Okay, now for part B. Area is again by the same formula pi r squared. But since in this case we are given with the diameter, so that will be radius is obviously 3.1 divided by 2, half of the diameter, that is the radius. So simplifying it, and let me use the exact value, 3.1 divided by 2, and its whole square. So the complete answer using the value of pi is 7.54767635. So retaining our answer to three significant figures, this will be 7.55. This is the fourth digit. So this is greater than 5. So we need to round it up to 5. So 7.55 meter squared. Area has to be in square units. In previous part A as well. I'm not sure whether I wrote it in meter squares or not, but its answer has to be 50.3 meter squares. Okay. Now for the circumference, 2 pi r, or we can use pi times d in this case. Pi times 3.1. This has to be in millimeter squares because in this the unit is millimeter. So pi times 3.1, that will give us the answer, which is 9.738. 937,226. So rounding it off to three significant figures, we should be having 9.74. Since this digit is greater than 5, so the previous digit, that is 3, would be rounded up. So 9.74 millimeter. That is the answer to the circumference of the circle given to three significant figures. Okay. And the same way part C needs to be done. And for part D, we are given with the radius, that is half a centimeter or 0.5 centimeter. So we can apply the same formulas for area and circumference, and we can calculate the answers likewise. Now we proceed to question number 2. Calculate the area of the shaded region in each case. Give your answers to three significant figures where necessary. In part A, we see we have got a square inside a circle. So we would be calculating the area that is required, that is area of circle. From this we need to subtract the area of the square. Okay, first of all, area of circle. Area of the circle, that is given by the formula pi r squared, pi as it is radius. In this case, you see up till here, we are given with the diameter, that is 18. So the radius is going to be half of that, 18 by 2, that is 9. So 9 squared. So area of the circle is going to be 81 pi. Now area of the square, that is equal to length square. In this case, we see that the length of the square is 2. So it will be 2 squared, that is 4. So substituting these values, area of the circle, that is 81 pi minus 4. Using our calculator, we can find out the answer. 81 times pi From this, we need to subtract 4. So the answer is 250.469, the complete answer. Two 50.4. Since the fourth digit is less than 5, so rounding it off to three significant figures, we should be having 250. And since the unit was centimeter, so it has to be centimeter square. So this is how we can calculate the area of the required yellow shaded region. Now for part B, we see that now the circle has been enclosed in a square. So required area will be equal to area of square minus area of circle. So area of square, that is 8 times 8, 8 square, that is 64. And from this, we need to subtract the area of circle, which is given by the formula pi r squared. And in this case, this is the diameter, which is 8. So the radius is going to be half of that, that is 4. So pi times 4 squared, that is 16 pi. 64 minus 16 pi. Using your calculator, we can find out 64 minus 16 times pi, which is 13.734. So the complete answer to three significant figures is 13.7 centimeters squares. Okay. In the same way, this is part C now. Required area is actually equal to area of the rectangle minus area of small circle and then area of the larger circle. Okay. Area of the rectangle, that is given by the formula length times breadth, that is 12 times 7, 84 meter squares. Now area of the small circle, that is given by the formula pi r square, that is pi times 1, because the radius of the small circle is 1 meters. So this will be equal to pi. And now area of the large circle. The larger circle is having a radius of 2 meters. So this will be 2 meters squares. That is 4 pi. So finally, the required area is area of the rectangle. That is 84 minus this one minus this one, which is 4 pi. 84 minus 5 pi. And using our calculator, we can find out the final answer. 84 minus 5 times pi. 68.29. Rounding it off to three significant figures, 68.3 meter squares. So this is the answer to part C. Now for part D, we can see that the required region is actually the area of the circle, which needs to be subtracted from the area of the triangle. So area of triangle, from this we need to subtract the area of the circle. So area of the triangle is given by the formula half base times height. Base is 10 and height is 15, which will give us 75 centimeter squares. And now area of the circle, using the formula pi r squared, pi times 5 by 2 whole square, because this 5 is actually the diameter, so the radius will be half of the diameter, that is 5 divided by 2, that is 2.5. So a required area can be calculated as required area 75, this one, minus 2.5 squared pi, because when we will divide 5 by 2, that will be 2.5 and then square of that and times pi. Now let me use my calculator to solve it out. 75 minus 2.5 squared times pi. The answer is 55.365. So giving the answer to three significant figures, 55.4, because the fourth digit is greater than 5. So this digit 3 will be rounded up. So the answer will be 55.4, and giving the answer with the correct units, that is centimeter squares for area. So this is how it is to be done. And now it is part E. Required area is actually equal to area of the trapezium. From this, I need to subtract area of the circle. Area of the trapezium is given by the formula half times sum of the parallel sides a plus b times height 1 by 2. And now the parallel sides are 12 and 19 times height, the perpendicular distance between these parallel sides. So this is 31 divided by 2 times 15. That is 232.5. And area of the circle, that is pi r squared. Pi times the radius is 5 squared, that is 25 pi. So the required area is 232.5 minus 25 pi. Using my calculator, now I can give the complete answer. 232.5 minus 25 times pi. 153.96. And the answer, when rounded off to three significant figures, will be, now this is the fourth digit which is greater than 5. So instead of 153.9, I will be writing it down to 154. And the units will be centimeters square. So this is how these questions are to be done.